Okay, I'm hopeful that in this video we can go through some of the different examples of solving log and exponential equations. It's confusing. I haven't been there, so hopefully do these 8 examples and clear up some confusion. Okay, so the first one is we have a log equal to a log. If the logs are equal, the arguments are equal. So I have an argument of x plus 2. And I have an argument of 3x minus 7. What happens to the logs? They disappear. There's a property that says logs are the same, arguments must be the same. So subtract x, add 7, x is 9/2. That is it. Okay, the next one, I have 2 logs, and there's no log on the right-hand side. Right? There's no log here. What am I supposed to do? Okay, so the first thing we're going to do is subtract logs, divide arguments. Subtract logs, divide arguments. Okay, now it's in log form. So we're going to switch it to exponential form. So the base is 10. So 10 cubed equals x over 5. That's 1,000. Multiply both sides by 5, and x is 5,000. Okay. The next one, there are no logs in this problem at all. Hopefully, though, you recognize that 25 is 5 squared. So this type of problem you've already done. It's just been a while. And 125 is 5 cubed. And if you remember, the only way that you're going to turn that fraction into a whole number is with a negative exponent. So this is 5 to the 2x equals 5 to the negative 3. Bases are the same, exponents are the same. Bases are the same, exponents must be the same. Divide by 2. So in number 3, bases are the same, exponents are the same. In number 1, bases are the same, arguments are the same. All right, number 4. So what happens when I can't rewrite using the same base? So first of all, there are no logs in this problem. And I cannot rewrite 18 with a base of 5. Like, that makes no sense. So the first thing I'm going to do is divide both sides by 3. You cannot multiply 3 times 5. That's voodoo. 5 to the x plus 4 equals 6. So now I'm stuck because in the previous problem in number 3, I could rewrite using a base of 5. They were the same. In number 4, I don't have that option. So it's in exponential form. I'm going to convert it to log form. So it's the opposite of number 2. Number 2 was in log form. We switched to exponential. This one's an exponential. We're going to switch to log. The base is 5, so it becomes the log base 5 of 6 equals x plus 4. Subtract 4 from both sides. And do this so that you don't confuse. Because if you don't put the parentheses there, like if you write it as the log base 5 of 6 minus 4, then you might get confused and think that's the log base 5 of 2, which is 100% incorrect. So, parentheses, very helpful. Okay. Let's keep on moving along. Each one of these examples is a bit different, so I'm hopeful that you'll maybe have a better sense of what's going on. Okay, so I have 2 logs, add logs, multiply arguments. Oops, sorry. Okay, it's in log form. I don't have a log on the right. There's no log here, so I can't say, oh, the arguments must be the same. I have to change forms. So when I change forms, I'm going to get 2 to the first equals x times x minus 1. 2 equals x squared minus x. Okay, so what do I need to do? Set it equal to 0, factor quadratic formula. Factors as x minus 2, x plus 1. If you need to, make your diamond, etc., etc. 0 product property. Okay, but then you got to check. If you plug -1 in, you get a negative argument. Never can you have a negative argument. So the answer is just 2. If you plug in -1, this becomes the log base 2 of -1, and that's not allowed. You're never allowed to have a negative argument. Okay, number 6. I see 4 and I think 2 squared. (32), okay. So first of all, cube root of 32 is 32 to the 1/3. Square root, 1/2. Cube root, 1/3. Fourth root, 1/4. I'm going to distribute and get 2x minus 10. So there's a bunch going on still. So 32 is 2 to the 5th. You can't see me, but I'm counting on my fingers. 2 times 2 times 2 times 2 times 2. It's 2 to the 5th. Multiply the exponents. This is 1 over 2 to the 5/3. To get rid of that fraction, this becomes 2 to the negative 5/3. Equal base, equal exponents. 2x minus 10 equals negative 5/3. Add 10 to both sides. Let's see. I think that's 25/3. I don't know, that is 30 over, yeah. And then divide both sides by 2, and you get 25/6. When you divide by 2, it's the same thing as multiplying by 1/2. 25/6. Okay, let's move it right along. Okay, number 7. We have to isolate 7 to the x minus 1. Subtract 6. And by the way, that's not 14. This is not 14 to the x minus 1. Subtract 6. Divide by 2. All right. I cannot raise 7 to a power or 3/2 to a power. I need to change forms. So it's an exponential form, change it to log form. So this becomes the log base 7 of 3/2 equals x minus 1. Add 1 to both sides. So actually I'm going to put the 1 in front. That's the answer. All right, last one. I have 2 logs, add logs, multiply arguments. Okay, I've got a log on the left with a base of an 11. I've got a log on the right with a base of an 11. Equal base, equal arguments. Okay, it's a quadratic. Set it equal to 0. So add 3x to both sides. Subtract 4. Do your diamond. A is 1. Check. And neither one of these answers work. Neither one works. If you plug in, I'm just going to rewrite the original problem at the bottom here. I'm out of room. Okay, if you plug in 4, so if you make this 4, negative, can't happen. If you plug in -1, can't happen. No solution. And that's that.